Alright, just a quick video about three-dimensional shapes. We'll study these a little bit more when we start talking about the ideas of volume and surface area in subsequent videos. But we, for the most part, are going to focus our attention on kind of the three-dimensional analog of polygons. They're called polyhedra, or a singular one is called a polyhedron. And they're made up of a bunch of polygons. So what is a polyhedra? It's a closed figure in 3 dimensions made from non-intersecting polygons. So here are 2 examples here. We have, basically you could think of this as a cube. I try to make every side here as equal as possible. So this is a cube. And this is called, hopefully, I drew it so that it looks okay, a square pyramid. I want this base to be a square, and it's a square pyramid. And you can see that each of these figures has a bunch of polygons that make it up. For the cube, it's a bunch of squares. For this square pyramid, you have a square as your base, and the sides are triangles. Now there's 3 important parts to polyhedra. They are the faces. They're just the polygons that make this up. For the first one, the cube, we have 6 faces. The top, the bottom, the front, the back, the left side, the right side, just like a standard die. The faces on our square pyramid, there are 5 of them. There's the base, and there are the 4 triangular sides. And of course, where these faces meet, they form a line segment we call an edge. So this cube, you can count how many edges it has. Let's count the front edges. It has 1, 2, 3, 4. Let's count the back edges, 5, 6, 7, 8. So we have all the ones that are on the front and the back. The ones that we're missing are the ones that kind of join those. So the 9, 10, 11, and 12 edges. So a cube has 12 edges. This square pyramid has 1, 2, 3, 4 on the base, and then 1, 2, 3, 4 that make up the side. So there are 8 edges for the square pyramid. And for vertices, that's just you can think of it as the corners. It's where the edges meet. So in a square, we have 1, 2, 3, 4, and then back 5, 6, 7, 8 vertices. And for the square pyramid, we have 1, 2, 3, 4 from the square, and then just 1 up top, 5 vertices. So they're kind of the parts of polyhedra that we care about. And we're going to limit our study, for the most part, to 2 classes of polyhedra. We're going to call them prisms and pyramids. So I'll tell you what they are in the next slide. The first class are prisms. And prisms consist of 2 congruent polygons sitting in different planes in space. So here's our congruent polygon. This is the first base, we call it, these 2 congruent polygons. And we have the same one sitting in a different plane, a parallel plane, above it. So we have those. And to get the other faces of our prism, so there's the left face, the right face, and the front face here. Well, we just take each corresponding vertex, so the one that matches up in the top base with the one that's in the bottom base. I think that's pretty easy to see. So you just join them up, and that creates our either rectangular or parallelogram sides. If the bases lie directly on top of each other, so if you draw a line from the middle of your top base to the bottom base, if you get something that's perpendicular to your base here, then it's going to be, we call it a right triangular prism. You can think of like a deck of cards or something that's perfectly straight. And that way you have your rectangular lateral faces. If you have your face moved over a little bit, we call that an oblique prism. Here's an oblique triangular prism. So rather than being directly above it, it's off to the side a little bit. You can kind of think of it a little easier when it comes to these rectangular prisms. So think of it like a deck of cards. If you had a deck of cards and you straighten it all out, that would be a rectangular prism. But if you give one of the sides of the deck of cards a little flick, one of the lateral faces, then the cards kind of shift over and it starts to look more like an oblique rectangular prism. The top card isn't directly above the bottom card. For the most part, we're going to focus on right prisms. So when I just say a prism and I don't specify if it's right or oblique, then just assume it's right. If it's oblique, I'll specifically mention it's oblique. And we can have regular prisms. That's when the bases are regular polygons. This is a regular pentagonal prism. And there are some nice relationships between, say, the number of faces and the number of edges and the number of vertices. And you can explore that in various exercises that you might have to do. The other class of polyhedra I want to talk about are pyramids. And they, rather than having two bases, they just have one. So the idea is you have this base here, and you put it on your table or on some flat surface. You pick some point that's not on that same surface, that's not in the plane. And to get the sides of your pyramid, you just join the point to each of the vertices of your base. And that gives you your lateral faces, we call them. And your lateral faces are always triangles. Since they're made up of three lines, you have the one side is your base, and the other two are going to be those connections to that chosen point, which we call the apex of our pyramid. For the most part, our study is going to be limited to regular pyramids, where both the base is a regular polygon and the apex is directly over the center of our base. So here is a regular square pyramid, here's a regular pentagonal pyramid. Again, you don't have to have the apex directly over the center. You can have it somewhere else, and then the pyramid just is a little crooked. And that's all I really want to talk about in terms of our polyhedra. We will deal with some related shapes as well, like a cylinder, which is kind of a circle version of a prism, and a cone, which is a circle version of a pyramid. But we'll tell you about those once we get into the chapter where we talk about volume and surface area.